example of series notation. So first example is the sigma notation of n squared minus 1 if n is equals to 3 going to 6. So 3 squared minus 1 plus 4 squared minus 1 plus 5 squared minus 1 and plus 6 squared minus 1. So 3 squared minus 1 is equals to 8 and 4 squared minus 1 is equals to 15. 5 squared minus 1 is equals to 24 and 6 squared minus 1 is equals to 35. So when you add it, 8 plus 15 plus 34 plus 35 is equals to 82. So the second example is here, sigma notation of 3n if n is equals to 2 going to 4. So 3 squared plus 3 cubed plus 3 to the power of 4. If 3 squared is 9, 3 cubed is 27 plus 3 to the power of 4 is 81. So 9 plus 27 plus 81, the answer is 117. That's all, guys.
So, good day everyone. So today we are going to discuss about the trigonometric function given an angle. So here we have an example of theta is equals to 5 pi over 3. So first thing is just to sketch the angle. So alright. So by sketching the angle, we understand that the half of the circle is 1 pi. So, that 1 pi in the term of right denominator, that is 3 pi over 3. Well, this angle is bigger, so this angle is bigger than the 3 pi over 3. So, we need to take all the way to here. Around here in the circle, which would be 2 pi, which is the same thing as the 6 pi over 3. Obviously, this angle is bigger than this angle, so we were going to adjust the angle. So we can see that we're almost half there, but we're not going to take it as the whole circle because we're just going to put the 5 pi over 3. So it is estimated around here. So here. So this would take us pi over 3. 2. So, step 2 is to identify the reference angle. Remember that the reference angle is in the positive acute angle between the terminal side and the x-axis. So, here. So, we all know that the theta pi is equal to pi over, it's equal to pi over 3. Next is step 3. So, for the step 3 is to find the point on the unit circle for our reference angle, which quadrant? So, it is on the first quadrant. So, here. So, this angle is 4 pi over 3. And this coordinate point, 1/2, comma, square root of 3 over 2. So, that is our coordinate. So, the fourth step is to find the coordinate point. Once we get to this point, everything else is rather simple. So since our coordinate is in the fourth quadrant, so we will going to have a positive and negative coordinate. So we will have positive 1/2 and negative square root of 3 over 2. So at this point, we can easily determine the value of sine theta, cosine theta, and the tangent theta. So the value of our sine theta is 3 over 2, while the value of our cosine theta is 1/2, and the tangent theta is square root of 3 over 2. So that would be all. Thank you.
Hi guys, this video is all about evaluating trigonometric function given a point on the terminal side. So if you have given a point negative 5 over 12, and by finding the sixth trigonometric function, you need to use the right triangle trigonometry. So we need to plot this point. Imagining negative 5 is in the left side and positive 12 is there. So negative 5 is in there, the adjacent, and the opposite is 12. So we need to find the hypotenuse side. So our hypotenuse is 13. So how we find 13? So we use this formula. Hypotenuse equals e squared plus b squared. So e squared is negative 5 squared is equal to 25, and 12 squared is equal to 144. So 25 plus 144 is equal to 169. So the square root of 169 is 13. So this would be our hypotenuse. So now let's find the sine theta in trigonometric function. So sine theta is opposite over hypotenuse. So our opposite is 12, and our hypotenuse is equal to 13. So second is to find the cosine theta. So cosine theta is adjacent over hypotenuse. So our adjacent is equal to negative 5, and our hypotenuse is equal to 13. So next is to find the tangent theta. Tangent theta is opposite over adjacent. So our opposite value is 12 and our adjacent is negative 5. So let's move on to cosecant theta. So this sine theta, let's like to flip or reciprocal of this, the value will be the cosecant theta. So it would be 13 over 12. And next is secant theta. Secant theta will be the reciprocal of the cosecant. So it would be 13 over negative 5. And lastly, the cotangent theta. So this is the reciprocal of tangent theta. It would be negative 5 over 12.
So in this example of the triangle, we're just gonna have to find the sine, the cosine, and tangent of the angle D. And by that, we're just gonna simply put the sine of angle D here, cosine of angle D, and tangent of angle D. The way we get the sine of angle D is by following the method, which is we're gonna find first the opposite sine over the hypotenuse. So it's gonna be 6 over square root of 2 and square root of 13. 13. And this basically our answer, but we could also reduce this. So it's going to be 6 divided by 2, it's going to be 3 over the square root of 13. And we could also rationalize this by multiplying top of top by negative square root of 13 over the square root of 13, and we get our answer 3 to the square root of 13 over over square root of 13, and square root of 13 is going to simply put 13. And the way we get the cosine of angle D is by finding the adjacent over the hypotenuse. So we're going to put the adjacent first. So it's going to be 4 over the square root of 2 square root of 13. And reduce it, equals to 4 divided by 2 will be 2 square root of 13. And we're gonna do the same thing as we did here. So we're gonna multiply square root of 13 over the square root of 13. That's gonna be basically the answer will be 2, and the square root of 13 will be over 13. And the way that we get the tangent D is by finding first the opposite over the adjacent. So our opposite will be 6 over 4, and we just simply get our answer, reduce it, and 6 divided by 4, we got 3 halves. And we got our answer. Sine of angle D is 3 over square root of 13 over 13, and cosine of angle D is 2 square root of 13 over 13, and tangent D is 3 halves.